Okay, here's our quick lesson on inverse functions. This is also something that you're going to see quite a lot of in Algebra 2. A lot of Algebra 2 actually is inverse functions from things that you've learned so far in Algebra 1. So let's talk about what that even means. First of all, a function, just a regular function, most of you know that means it passes the vertical line test, or each input has only one output. And I just want you to remember that to note a function, we write f of x. When we talk about inverse functions, we're talking about something that is written as f negative 1 of x. All right, so this little, if you ever see this little negative 1 sign up here, and that just means we're talking about the inverse function. That's how you write that. And inverse, I think, should probably make you think, the word itself, that you're going to be doing the opposite. So in this case, to do the opposite of something or to undo something, to find inverse functions, we're going to switch the x and the y values. So the example that is actually shown here, you're going to put in your notes, and I want to show you kind of how this works. So the original function would have been, and I'll write in red here, I'm just trying to color coordinate for us, is y equals x squared plus 1. All right, so that's my original function, and it gives me a parabola. I know that it's going to cross the y-axis at 1. The inverse function, then, if I switch the x and the y, the inverse function that I get, shown right here in green, is going to be x equals y squared plus 1. And notice what that does. You should see it's the same kind of parabola, except it's been like turned on its side because it's x equals instead of y equals. The other thing, because we're switching x and y, what happens to the graph is the graph becomes, and we need to write this down, the graph becomes a mirror image, or we call that a reflection. You're used to reflection meaning it flips down. So it becomes a mirror image or a reflection across the line y equals x. Because if you think about it, the whole purpose of inverses is to switch the y and the x. So we're saying that they're equal to each other so we can change them out however we want to. All right, so notice, hopefully you're seeing that in the graph, that if you folded across this blue line, this pink parabola would become the green parabola if you folded it across. All right, so let's look at what these look like. We have two examples today. Okay, so the first one is going to be for us to find an inverse and to graph it. So I'm going to start by just graphing this original function, and I'll graph it in blue. All right, so that's going to be negative 4, negative 3, if I plot that point, negative 1, and 0, 3. Okay, so this function right here, if I connect it, got that kind of looking shape right there. Now, inverse, that's f negative 1 of x, means that I'm going to switch the x and the y values. So instead of negative 4, negative 3, my first point is going to be negative 3, negative 4. Instead of negative 1, my next point is going to be negative 1, negative 1. So notice sometimes when you switch them, it doesn't actually change the order. And then the last point is going to be 3, 0. So now when I graph these, negative 3, negative 4, negative 1, and 3, 0, we should see a kind of mirror image appear. And it is true that if I went and I graphed that y equals x line, which is just a diagonal line straight through the graph, you should see that those mirror across that green line or that y equals x line. That is how you can check, is by checking that you're getting a mirror image. And if you are, you know what you've done is correct. All right, last example is how to find inverses from equations. So the first thing, they're going to give you the original function and say f of x. We've learned before this year that that's another way of just saying y equals 3x minus 8. And then to find the inverse, we said we have to switch the x and the y. So this becomes x equals, here, and I'll write in a different color, x equals 3y minus 8. Now we do need to go back and actually solve for y. So I'm going to move my 8 over. It's going to give me x plus 8 equals 3y. And then I need to divide by 3 to get y by itself, which is going to give me the function y equals x plus 8 over 3. And since this is an inverse, we're going to write it f inverse, that's the f with the little -1, equals x plus 8 over 3. So now this x plus 8 over 3 and 3x minus 8 are inverses of one another. If we used our calculator to graph, they would be mirror images of one another. What I want to show you, though, specifically about the inverses is I just want you to see when you look at these equations, hopefully you notice some things. For example, what's the opposite of minus 8? Plus 8. All right, so they have opposite operations there. And then what's the opposite of multiplying by 3? Well, it's dividing by 3. Now, I'm not saying you can skip from here all the way to there just by doing that, but it is one way to kind of check that you're in the right ballpark, is that you should end up with opposite operations for your new equation.